So I'm Teddy. I'm a PhD candidate at the University of Calgary, just finishing up in August. So what work we did here at Microsoft Research is something called Project Alava. So what it's about at a high level, and James will kind of explain a little bit more later, is we're making it really easy for people to program microcontrollers, so things that are kind of small computers. They're typically hard for people who are non-technical to code. And obviously, if you think about people in sort of the broader world, there's a lot of people that are really creative, but also maybe not so technical. And so what we looked at was making it easy for them to be creative with technology. One of the first examples we looked at was fashion. So what we designed was these things called brains and something called a bead. So the brain is something you would code in a browser using MakeCode, which we'll kind of explain a little bit shortly, and a bead. So a bead is something like a sensor. And so we did things like making it very color-coded, so you kind of know what the sensor looks like and what kind of functionality it has. So functionality can be things like an accelerometer, proximity, or color. As I said, these are all programmed in the browser. We also did things like smart tattoos. So Asta Roseway, who's a fashion technologist and a creative engineer here at Microsoft Research, she does things with smart tattoos. So we made it easy for people to be able to cut these tattoos and program them into the browser. In this demo here, you kind of see we have what I mentioned was the brain. So that's this thing up here. And a bunch of different sensors hooked up to it using audio jack cables, which uses a protocol called jack, which James will kind of explain in a moment. And if you kind of look over here, we have a tattoo sensor. And so if I touch her hand, it should light up. So we made it really easy for people that are creative, specifically fashion designers, to do things like this. We ran a full fashion show in New York with 22 designers comparing traditional fashion design with tech infused into it. And they all created different types of garments. And that is what we did with Project Alava. And I'll now hand it off to James.
Hi, I'm James Devine. I'm from Lancaster University. I'm a PhD candidate there. So Teddy mentioned one of the big challenges was the programming environment, and I'm going to highlight the programming environment on this computer here. So this is MakeCode. I'll make it bigger. It's a block-based programming environment primarily. It's drag and drop programming, so I can drag and drop, click my blocks together very much like Scratch. And then if I get super proficient with the blocks, I can then progress to JavaScript and even Python. So it's quite a full-featured environment. For all intents and purposes, it looks like a very high-level language, but it actually runs at the speed of C and C++. So that's kind of the interesting thing. And so that enables us to run on these tiny microcontrollers that Teddy was talking about earlier. Another challenge was the connecting of these devices and the networking of these devices together. Teddy mentioned we've been using the audio jack. So we developed a new serial protocol called JackDAC, and it runs over the audio jack. And the audio jack provides power, data, and ground. And JackDAC is designed to be very dynamic and plug and play. And the reason for this is that for fashion designers, they're not electronics engineers. They have no real ability. So we wanted to make it super easy for these designers to come in, plug different microcontrollers together and build their applications using an easy programming environment and an intuitive protocol. So I've got a little demo here. I'm not sure if you got it. Okay. So when I shake my motion bead, which is an accelerometer, you'll see the lights at the back turn on. And that's all using the protocol. And the protocol, as I mentioned, is designed to be dynamic. Let me find I'll move the tab, sorry, my bad. And some of these devices also operate USB. So we can connect one of these devices. So this one's running both JackDAC here. It's connected to the JackDAC bus. And it's also connected over USB. And using the power of Web USB, I can connect to that device. And I can visualize the activity that's happening on the bus. So I get a list of my devices and a list of packets that are currently being sent on the bus. And I can shake it, and you can see the lights turning on, and you can see the packets appearing. And that's Project Alava.